Hardly there will be any field which do not use the simulation technique, whether it is gambling, statistics, or risk analysis, or trading, or DNA sequencing. Simulation technique is simply indispensable. Hello and welcome to this new video on my channel of the office. Today's video will discuss the application of rand between function, a very useful function of Excel, in effectuating this simulation with an ease. First of all, let's see the syntax of this rand between function, RANDB. So this function takes two arguments, top and bottom, which actually are the lower and upper limit in the range of which we want to generate the random values. Some of you might be aware of the old rand function, which generates a value between 0 and 1. But this function can generate random numbers between two numbers, like rand between. So if I want to generate a number between, say, 1 to 100, 1 and 100 are inclusive, then it easily generates a random number. Similarly, say if I want to fill this whole place with a random number between 0 and 99 and press Ctrl Enter, the whole cells will be filled with a random number between 0 to 99. But this is a volatile function, and every time you press Ctrl equal to or press F9, the values are refreshed. So if we want to stop that, we need to use paste special to check the auto refreshing. Alternatively, people who are aware with a bit of VBA can generate a simple user defined functions where we can write a simple one line coding for a subroutine and just set the application.volatile to false instead of the default value of true. With rand between function, we can play a simple dice game. I'm showing you these two places. Simply I'm using a rand between function. I want to have numbers between 1 to 6, and if you press enter, similarly the same formula has to be applied here as well. Rand between 1 comma 6. So every time I press F9, the values are refreshed as it is a volatile function. Now random function might look a simple function just for randomizing numbers, but it is of immense use in simulating predictions. I will demonstrate a simple simulation through Monte Carlo method, and we have a simple situation before us. The question is, in any country 30% are having O blood group, and as you know, O blood group is a universal donor. So if 30% of people are having O blood group, then 69% of the people will be having non-O blood. So the question here is, what minimum number of people are to be sampled so that we get 3 persons at least with O blood group. So we will follow some steps here. The first step will be finding out the probability of the event that I'm going to check simulation for. So the probability of that event, that is like having O blood group donor, is 31%. So this will be set to 31, and non-O donors will be 69%, right? And then we will create cumulative probability. So this is also 31, while for this will be 99%, right? And then while we have set our cumulative probability, we will prepare class interval for these probabilities. The probability will always start from 0% to 1% less than what we have. So 0 to 30 becomes 31 in count, and then 31% to 99%. So what we have to do is, now we have to fetch some random numbers to a given table. So in Excel we have rand between function with us to help us to generate us the random numbers. I will try generating, or I will start generating the random numbers in my first trial, and the moment I get the third person with O blood group, I will stop then and there. So in first trial I will generate 40 numbers between 0 to 99. So my aim is to generate 40 numbers from 0 to 99. So the function we have is rand between 0 comma 99 and press Ctrl Enter. So I have to check the nth observation where I am encountering the third O blood group donor. So I will apply a formula here. So before doing that, I will copy this and I will copy this to around 50 trials. As many as trials you take, your result will be more precise. So now I'm going to check what is that nth observation where I'm encountering a value equal to or less than 31. I'm just checking. I will lock it. So if it is less than 31, then this will give me a true, right? You can check true false here, true false, true false. Then, and if in case I encounter this true false, what I need to do, I will wrap it inside an if function and say if I encounter a true, I want there 1, if false then 0, if again then I encounter a true then 3, and for after 5 data I'm getting nothing, and the 10th data is true, so I will get a true there. So I will generate a sequence of number from 0 to 40 because I have 40 observations. So rows 40, and you know the default values of column start step is 1. So if you leave it to here, this will generate a sequence of number from 1 to 40. So if it is so, then you can check what it is returning to me. As I can see, this is giving me 1 because that value was less than 31. Then the fifth position it gave me 5, and other places it is giving me false. So if it is so, now what I will do, I will copy this array, and now I will find its third position because I want to have my third occurrence of that data. So I'm using small and comma 3. This gives me my third occurrence of data, and see what it is giving. This is giving me 8. So what is 8? 8 is the 8th position. So now I will use match function. Match, my lookup value will be the same. My lookup value will be the same. Lookup value will be 8, and where I am going to search it, the one that I have just pasted, and this will give you an array. So I'm trying to find 8 in this array, and my match is exact match, and that's it. This is giving me 7. So now I can say in this trial I'm getting 3 O donors after 7th observation. When I copy this formula to here, to the 50th trial, sorry, I have just logged this, that is why this is happening. So I need to unlock the column 1, the column part, in here as well. B8, B has been freed. Here also B had been freed, and then, and if now I copy it, so this will give you different results. This trial is giving me 10 as my result, that which means that I'm getting the third donor after sampling the 10 peoples or 10 people. This is giving me 8, 13. So what I need to do now is I will average these values. I can simply average this value, average here to here. I can lock it, no issues. But this is giving me a value in decimal. So if it is 10, then I will leave it to 10 here. But if it is in decimal, then there can't be 10.06 people. So I will round it to the next integer. So let me copy it first. Control C, and insert a simple if statement that if the value that I have just obtained is average is equal to int, then what I want, if it is same, then I will have the same value. But if that is not the case, then I will add 1 to that and find integer of that value. So now it is perfectly okay. For your reference, I have copied down these formula. Quickly go through the steps that Monte Carlo technique uses for simulation. That is, you just need to find first of all the probability distribution of events. right? And then you will find the cumulative probability of all those events, like 33%, 69%. And then you will set a class interval of cumulative probabilities. You need to have one thing in mind, that probability will always start with 0 and finish with 99. So, and now having done that, having created that table, we need random numbers. Either you can use a table that is given in an examination, or in Excel you have a very beautiful function, rand between function. You can generate random values or as per your requirement, and then we will iterate these trials as many as times to get better approximation. And once done, finally we will take average and round up to the nearest integer. So that's it in this video. Hope you liked it. If so, do not forget to subscribe, share, and do press bell icon so that you receive notification of all new videos. Thanks for watching.